Can you see the screen?
Yes, sir.
Right. So this is the ANOVA table for a CRD. So we said we can test this for treatment effect. So, sorry, other way around. We can test this for treatment effect. So what about the second component? Test for what? What is, because you see here, it is something to do with regression. So here we can test whether covariate is significant. We can test whether covariate is significant. Can you explain this in our previous calf weight example? Can somebody explain what we are going to test in calf weight example? What is the covariate that we took in calf weight?
Initial weight.
Initial weight. So we want to see whether initial weight is significant. Whether it is initial weight is significantly different. If the initial weight is not significantly different, do we need to go for analysis of covariance? If the initial weight is not significantly different, is it necessary to go for analysis of covariance?
No.
No. Then what we can do in that circumstance?
We can do directly ANOVA.
Yes, we can do directly ANOVA. We don't want, because if the covariate is not significant, then no point of taking the covariance analysis. That means not significant means the initial weight are more or less closer to each other. If we come across and say the covariate is not significant, then we can say the initial weights are more or less same. So that no point of going for ANOVA, right? So that
initial weight வந்து significant இருக்குன்னு சொல்றது அதோட கருத்து initial weight ஆல வந்து weight gainல ஒரு பாதிப்பு இருக்குது ஒரு எஃபெக்ட் இருக்குன்றது சொல்றேன்.
இல்ல இங்க நாங்க பார்க்கிறோம் வந்த அனிமல்ஸ்ல இனிஷியல் வெயிட்ல பெரிய வித்தியாசம் இருக்கோ இல்லையோன்னு தான் பார்க்கிறோம். Yeah, what you said is correct, because it is ultimately contributing. Whether initial weight is contributing to the weight increase, right? Yeah, ultimately what you ask is correct. So let's say this is the weight gain. This is the variability in weight gain. This is due to treatment. This is due to covariate. In our case, initial weight.
Okay.
Right? So we test whether it is a significant or not. Sometimes in another case, maybe this is covariate. You see? So compared to the first case, the second case, the covariate or the initial weight is contributing very less to the weight gain. So that no point considering initial weight as one of the component, right? So here covariate is not necessary as an example, right? Okay, right. So this we can test it. So this is the setup. Then this is for CRD. If it is for preliminary information for RCB, this is for preliminary information for RCBD, right? Because we can do the analysis of covariance in RCBD also. So when it is in RCBD, we have one more component. What is that? Block is coming. Again, same x, y, x, y. Same story is coming, x, y, x, y. Now we have additional information that is block. Treatment residual total is always there. So these are some of the notations that we can use for calculation. I will send this also, then you can have a look. Then our ANOVA table. We have one more additional component compared to CRT. Here we have this information, blocks. Actually, it is earlier it was replicated, now it is block. So we can do ANOVA in RCBD also. Calculations are a little different. So you could see here, this is the block sums of square, which is adjusted. Then this is a treatment sums of square, which is also adjusted. Regression sums of square as usual. This is the total sums of square. This is the error sums of square. They are respective degrees of freedom as such. So regression always one. So here we have two variables. One is the covariate. The other one is response. We have two variables. We can calculate this. This is not usually with the same pattern of ANOVA. So this is totally different. Totally different calculations of sums of squares. Different concept. That is why it's covariate. You see, always it's coming with covariate. Right? Always X, Y. That is why it's called as covariate. Here also the same. Normally we don't do this, whether there's a block effect or not. Normally we don't test it, but if you want, you can test it. But we test it for treatment effect. If necessary, we test for the regression effect or the, what do you call, the covariate effect. Right, there's a small example. You can do it manually. Right, and try this. First, you look at it manually, then we will see how we can do it using computer. So these are the treatment: first treatment, second treatment, third treatment, fourth treatment. So this is something to do with formulation of industrial glue. You know, this gum are being tested. So the strength, you know, in engineering, you could have studied this tensile strength. Right? Response of the glue is known to be related to the thickness of the glue that you have applied. 5 observations on strength Y in pounds, let's say kilogram or pounds, and the thickness X, thickness of this glue that you have applied, X in 0.1 inch are made for each formulation. So thickness here, the strength is the response of Y, thickness is the, what is that? X covariate. It is a given in 0.1 inch, 0.01 inch. Right? So this is different thickness, different thickness for these values, not same, right? It's like initial weight, right? Thickness of the glue. So this is Y. So this is replicate. So this is given in CRD, right? Do it in CRD. There's no any block here. The first set of treatment, second set of treatment, third set of treatment. Right. Any questions? That's all from me, from experimental design, because there are so many other things, but this is more than enough for you all to do your experiments. Any questions? Any questions?